Good afternoon. Welcome. Welcome to this session. And, I didn't know that a lake existed till I actually walked past this conference room right now. So that was kind of interesting. Well, I hope Ignite has been treating you guys well so far. Before I begin, I just want to get a little bit more of an understanding of my audience. So could you please raise your hands if you attended my talk at MEC last year? Okay. That's good. I mean, there are a few hands, so we have a lot more who haven't, so which is great. How many of you still using Exchange 2010 and lower? Whoa, okay. Good. 2013? Oh, same hands go up again. Well, okay, let me ask this question. How many of you guys on your 4th cup of coffee? What, 8 of y'all? I mean, we have only 8 honest people in this audience, apparently. All right, let's get started. We have a full session here, full deck. I'm going to go through a bunch of concepts, start off with on-premise and transport deep dive, and then later on talk a little bit about Office 365 towards the end based on time. My name is Khushru Irani. I'm a program manager with the transport team for Office 365. Our team is responsible for managing mail flow for Office 365, the service, as well as the transport component that ships with Exchange. I mean, in short, we are glorified mailmen. So what we want to do today, or rather what I'd like to do is, so I want to start off with, since many of you are still on Exchange 2010, let's talk very briefly about the differences between 2010 and 2016. Now, those of you who are moving to 2013, 2016 and 2013 are very similar, and so a lot of what I'm talking about will hold true for 2013 also, except for the fact that if you've attended any of the other Exchange sessions, all components are on one box. There is no cafe anymore. It's all one box, the mailbox, right? So apart from that, though, a lot of similarity. We'll go into deep dive for each of the transport components that ship with Exchange 2016. We'll go through a few routing scenarios so you understand at the end of the day how routing will work with both 2013 and 2016. It's very similar. Transport high availability, and finally, Office 365 mail flow. So what's the major difference between 2010 and 2016, or even for that matter, 2010 and 2013? Now, if you remember in 2010, when you have mail coming in from the internet, it uses SMTP to talk to the hub. The hub, on the other hand, talks MAPI when it writes to the store. Now, you'll notice that, and I'll repeat this, keep repeating this, the hub, and when it talks MAPI, there are 2 different machines here. So MAPI is actually going across machines. That is changing in 2013 and 2016. To illustrate that point, so let's talk about the other hub receiving SMTP traffic in this case. That hub will send mail to the hub in the site where the mailbox is, and that hub will make a cross-machine MAPI write for that mail item into the store. Okay, so that's how 2010 in general operates. Now, if you are familiar with MAPI, MAPI in itself, I mean, it's a robust protocol, but when you talk about cross-machine, not so much. Even if you people have akin that to, for instance, opening File Explorer. You open File Explorer on your box, it works almost always rather. You open File Explorer to browse files over the network, it's mostly good, but sometimes not so much. And that's why in 2016, you will notice, as well as 2013, if there's one takeaway you want to make from these first few slides, it's that there is no cross-machine MAPI communication. Okay? All cross-machine communication will happen over SMTP, which is way more used to cross-machine talk. So I'll briefly highlight the components in 2016, and then we'll go deeper into them. You'll see that there are 3 components, in this case, all shipping on the same box. Not the case in 2013. You do have a cafe box in 2013 that has the front-end component. So you have 3 components: the front-end transport, and mailbox transport. Mail comes in via SMTP, always hits the front-end transport first. Okay, it doesn't matter whether it's on the mailbox server or on the cafe server, it always gets hit first. The front-end transport service will then talk SMTP to the transport service, which will then talk SMTP to mailbox transport, and mailbox transport is the only component that will actually talk MAPI locally on the machine. Now here everything is local, so that's good, but what if the mail came in, for instance, on the other front-end transport box? So it comes into front-end transport, and we'll be reiterating this a lot, so if you can't catch it in this first turn, by the end of the session, I'm sure you'll get that. So anyway, mail comes in via SMTP to the other box in this case. Front-end transport talks to transport on the local machine. Now, this service realizes that the mailbox actually exists on a different machine. So it will go cross-machine from transport to mailbox transport, not directly to the store via MAPI. It will go SMTP from transport to mailbox transport, and finally, mailbox transport will talk MAPI locally. So you can see the big difference between both of these is MAPI is local, and it's all cross-machine traffic is SMTP. We'll be doing more of the routing on 2016 a little bit later. The other thing, I don't know about you guys, but debugging SMTP is much easier. You look at the protocol logs, you look at the stuff, it's easy to understand the talk that goes on between these machines versus MAPI. Okay, moving on, so that's the big takeaway here. So we spoke about delivery. Let's give an overview. This is only an overview. As I said, we'll go into details later. What happens when mail, in 2010, what about submission? So you write a mail, you compose a mail, you press send. That mail, you get a notify MAPI call. The submission service gets a notify MAPI call. And the hub, again, talks MAPI cross-machine to get the mail item and communicates via SMTP outside. In 2016, on the other hand, the mailbox transport locally will again make a MAPI call, get the mail item, and then make a SMTP call to the transport service. It usually picks the transport service in another box for redundancy reasons. So it'll go to a transport service on another box, which will then send that mail out via SMTP. So again, the concept is really the same, both submission and delivery. The difference is cross-machine traffic is always going to be SMTP, and locally is MAPI. So the 3 components that I'm going to dive deeper into right now in the next slides are front-end transport, and mailbox transport. So of the 3 components, the transport service is the only service that is stateful. Now you might equate the transport service to, we used to call it hub transport to some extent in 2010. So it's similar. It's the same thing really. So you have front-end transport, you have transport and mailbox transport. One takeaway: transport is the only stateful component. It's the only place where your mail will be stored. Nowhere else, no other transport component stores that. Transport responsibilities remain unchanged. We receive and deliver all inbound mail to the organization. We submit and deliver all outbound mail to the organization. So inbound, outbound, that's our responsibility. We perform message processing, finding out routes, expanding distribution lists, and so on, and we'll talk more about that. Finally, we also have extensibility points built into the pipeline, where third parties can leverage those extensibility points to do things like processing the mail or changing the route of the mail, and so on. And finally, and I'll go deeper into this, is we will keep messages redundant much better than what we were doing in 2010. So that's the other big difference. Front-end transport. Now, front-end transport receives mail on port 25. Anonymous mail on port 25, authenticated mail on port 587. So if you were to connect to smtp.contoso.com, for instance, depending on which port you connected to, you would go to it will either accept anonymous or authenticated mail. In authenticated SMTP, you're talking about the client or the sender having to provide a username password to authenticate, much akin to folks doing client submission. I don't know if you have Thunderbird or one of those clients, that's using client submission via port 587. So the one change that has been made is that now we support TLS 1.2 in addition to 1.0 and 1.1. That shipped in CU 8, I believe, for 2013. So even 2013 gets TLS 1.2, as well as 2016 will too. The other thing to keep in mind with front-end transport is that on the way out, mail on the way out, you don't have to go through front-end transport. The transport service can send mail out, but in some cases people prefer to actually have the symmetry, so mail basically goes out via front-end transport just as it came in. To do that, you have to set the front-end proxy enable parameter on your send connector. Now, in terms of benefits of front-end transport, the primary thing to keep in mind, the primary role the front-end transport possesses is it looks at a piece of mail and finds the mailbox associated with that mail. When I say mailbox, I actually mean DAG. It finds out which DAG that user is in. And based on that, it will connect to the right transport service. And we'll talk about that a little bit more. The other thing is, obviously, it scales with the number of connections. You can send as many connections as you want. It'll spawn off new connections. It can go up to, I think, about 5,000 by default. Finally, it also supports SMTP extensibility points. So there are a bunch of extensibility points built into every stage of the SMTP protocol on ELO, on Connect, and you could have either third-party agents or write your own agents to hook into those points. All right, let's move to probably the core piece of transport here. We're talking about the edge transport.exe or the transport service, or previously known as hub transport, as I said. Most of you are familiar with this. One thing to keep in mind is because the front-end transport service is taken over port 25, it's the same box, the transport service will look at port 2525 for its SMTP mail, all right? And it will accept mail from both the mailbox transport service, you can see that on the bottom. It'll also accept mail from the front-end transport service. Oh, I can only do this on one of these screens. Okay. Finally, let's go to the next slide to talk a little bit more in depth. You know the drill in terms of we would accept mail both from outside as well as via port 2525, as well as if you put a mail item in the pickup or replay directory, we would pick that up too. Now the next slide actually has more details on what happens in this pipeline. So I have a piece of mail here that's coming in. One thing to keep in mind is that we will only accept mail or return back a 250 OK to the sender once we have saved a copy of that mail. So the first thing we'll do is that copy of the mail is actually saved in the mail.q database that is on the box. So mail comes in, gets saved there. Now that if we have a copy, we are ready to process it. That piece of mail will now get into the submission queue. The submission queue is where all incoming mail comes. There's only one of it. I think it has a limit of 10,000 messages or so. But mail comes into the submission queue, and it goes through this categorizer pipeline. A lot of good things happen in this categorizer pipeline. Let's walk through this list. So the first thing that we do when we get a piece of mail is we look at the recipients on that mail, and we resolve them. When I say resolve, I mean we will look up Active Directory, find out whether this is a mailbox. In some cases, it's a mail user or a mail contact. If it's a distribution list, we will find out that it's a distribution group, and we will expand membership for that group. All of these things happen at the resolve event. We would also convert things like convert from alias to primary address. That also happens during this phase. If there is a forwarding rule present, we would use the resolve during the resolve event. That's when we'll determine that this mail needs to get forwarded to another mailbox. So that's what happens. We resolve the recipients first. So now we know what we are dealing with, who they are. The next phase is to actually determine the route for these recipients. Some of these recipients have mailboxes on premise. Some of these recipients are external recipients. You could be sending a mail to somebody at Yahoo at the same time to your own somebody else in Contoso. Those routes are figured over here. So when we figure, and in some cases we are going to be applying, send connectors at this point, determining where to send that piece of mail. And in the last stage, that's when we would do things like, okay, this piece of mail is going to 2 recipients. We need to send one copy of the mail here and another copy of the mail there. We need to put the right addresses. We would also need to make sure that if you're sending mail outside, if the remote domain supports does not support TNEF, supports MIME, that's when we will convert the mail into a protocol that the other side understands, or format that the other side understands. All these things happen at content conversion and bifurcation during that step. Now, you have seen that during this entire process, there are like 4 lollipops that I've drawn there. Those are the extensibility points inside the transport service in the pipeline. Different agents subscribe to different points based on their needs. Sometimes some agents subscribe to multiple points. So, for instance, on the on-submitted, you have anti-malware usually is the first thing that works. As soon as it comes in, that is taken care at the on-submitted stage. Before anything else is processed, it can be thrown away. That mail can be thrown away if it contains malware. The transport agent, for instance, even before that, the journaling agent, the unjournaling agent would probably work, or the decryption agent also works, for instance, at the on-submitted stage. At the on-resolve, once you've resolved the components, that's where things like the transport rules go into play, because they deal with recipients once they're resolved based on the rules you have. After that, you're talking about on-routed. And during on-routed, again, you have instead of the unjournal agent, you have the journaling agent, for instance, that works on the routed, as well as sometimes you might need to change rules based on SMTP forwarding. That might also override the route that the mail is actually going to be taking. On categorized, I don't know of too many agents subscribing to that, but at the end of the day, that's the event available in case you want, after the whole categorization process is completed, you want to look at that mail item, that's your event to look at. Now, one thing to keep in mind is we only had one submission queue, but we have many delivery queues. Okay, these delivery queues, there's a delivery queue per destination. So if mail is going out to Yahoo, you will see a delivery queue for Yahoo. If it's going out to Gmail. If it's going out to mailboxes, you'll have different, depending on which database, because a mailbox can have multiple databases. Depending on which database it's going to, you will see a different delivery queue per database. So it's destination based. And so in this example, this piece of mail of mine, one piece of mail is going via the mailbox delivery queue to be submitted to the mailbox transport process, or sent to the mailbox transport process to get submitted, or get delivered rather. And the other piece of mail is going through the external delivery queue, also to be sent out, in this case, to some external destination. So that's kind of the general outlay of what the transport pipeline looks like. So just a quick recap in terms of the advantages here, or the benefits. All routing decisions take place inside the transport service. It is the place for extensibility. Most third-party agents actually hook up to extensibility points along this pipeline. The other thing is it protects messages by making a shadow copy, and I'll go through much more detail about that in subsequent slides. What about the mailbox transport process? The mailbox transport process, it's called mailbox transporter, but it's really two services on the box. You have the MS Exchange delivery service, and you have the MS Exchange submission service. Both are separate processes on the box. The delivery service is used to receive mail from the transport service, and then call MAPI to write that mail item to the store. Now, it receives mail on port 475 on that box. It also does any MIME to MAPI conversions. Now, one thing to keep in mind, you might notice there is actually a SMTP send component inside the delivery service, and you might be wondering why that is there. The reason for that is when you are trying to make a delivery, inbox rules act on the mail. Sometimes you have OOF messages that need to be generated. Those messages go out via the send component. Let's move on to MS Exchange submission. Now, the submission service, it subscribes to the event infrastructure service or the event assistance infrastructure service, like many other event assistants. What I mean by that is, when you click the send button, you'll notice that the mail actually goes in your outbox first if you're using Outlook, or it goes into the drafts folder if you're using OA. What's really happening is the store is now sending us a notification saying, hey, I have an item to send, I have an item to submit, I have an item to submit. And the submission service is the one that picks up that item from your outbox and then calls SMTP to send it to the transport service. So if you ever notice that users complaining that their mail is stuck in their drafts folder or in the outbox sometimes, it could quite possibly be the submission service on the box is not running. So these two services are very critical because they have direct user impact. User can perceive that. Because when you are trying to send a mail and the other person does not receive it and it's in your outbox still, that usually signifies, outside of Outlook issues, which are quite a few to discuss here, but outside of Outlook, the submission service is quite likely the reason why it's either stopped on the box or it's hung, and so you cannot send mail. The delivery service is equally important because if delivery service is not running on the box, people aren't getting their mail delivered to their mailboxes. They can't see their mails. Mail's most likely getting queued in the transport service. This component does not support extensibility, by the way. And the primary thing that and I keep repeating this, I'll say it one last time, is that the reason why this service is there, the mailbox transport service, is to be the component that talks MAPI. Okay? All right. Now let's move to somewhat of an architecture diagram. You probably have seen this before in some other sessions too. We have on the right an enterprise network. It is behind a load balancer. And you have, in this case, I've just shown you 3 DAGs with a bunch of mailbox servers in these DAGs. Each DAG, in this case, I don't know, I can have up to 16 mailbox servers. But there are 3 DAGs in this environment. And mail, basically, actually, before we go to that, one thing to keep in mind, the reason why I've drawn those dotted lines is because there's a load balancer or a WIP sitting in front of all these different front-end transport services, right? Any front-end transport service can get the first incoming mail, any incoming mail. Your WIP or your load balancer is just balancing between these front-end transport services. It doesn't really care which one it chooses as long as whatever mechanism it's using, round robin or whatever, it's going to send it to one of these front. It doesn't know where the mailbox resides. It just knows that it has a bunch of front-end transport services to send that mail to. So there are all these front-end transport services, one on each box. So when mail enters the organization, and it enters it from the internet. Now I have drawn, some people have Exchange Online Protection, or they might have other devices or other services that they use for spam. But the mail comes in, this is coming in from the internet. And in this case, our load balancer has picked up the front-end transport service on this one box. Okay, so it has picked up one of them. It sends that mail to that front-end transport service. The front-end transport service, I told you, one of its primary duties is to talk to Active Directory and figure out which DAG that mailbox, that recipient belongs to. So it queries AD and finds out that that particular recipient belongs to DAG 3. Now, it doesn't really care which mailbox server it sends in that DAG. What it cares about is that it has found the right DAG. So it knows it's on DAG 3, and it will send the piece of mail to the transport service that's running on a machine in that DAG. It usually prefers the transport service running on a mailbox server in its site. Okay, so it'll prefer that, but it'll pick any mailbox server that's in that DAG. So it sends that mail to that transport server. That's where all the processing takes place, the categorization, and so on. And the transport service now finds out, when it does the resolution, that's when it finds out, okay, this mailbox resides on this particular mailbox server in that DAG. And what's it going to do? It's going to basically, within the DAG, it can talk directly to the mailbox transport service. So it'll send mail to that mailbox transport service, which will locally write to that mailbox. So that's kind of the overview of how mail basically flows inside the organization. Now, no, I guess, talk would be complete without mentioning the edge role. The edge transport service, I'm not going to go into depth with it, but a lot of people still use the edge transport service. In fact, show of hands, how many people have edge transport running? Okay, fewer than I thought. Okay, that's good. That's good. I mean, I say that's good because I see fewer hands, and every year I see fewer hands come up, which is good. I mean, the reason why I say that is because, I mean, it's there, like its role is the same from 2010. It's the same in 2013. It's going to be the same in 2016. Role is that, hey, I don't want a machine that's attached to my Active Directory. I want a machine that's non-domain joined to accept mail before anything happens to that mail. And that's the sole purpose of the edge transport service. While that is good, because it is in the DMZ, as you can see, what's not good is that it doesn't have any AV by default. It doesn't have any anti-spam features by default, no shadow copy. So if your edge role died after accepting mail, that mail is lost. The other thing that it does not have, I mean, is, well, actually those are pretty much the only things. But that being said, the no AV and scarcity of anti-spam means that box is getting bombarded unless you have something sitting in front of it, either some kind of anti-spam service or a third-party software that's running on the edge box. Okay. So, and one more thing to keep in mind is client submission, the last point there, client submission traffic, so traffic over port 587 never goes via the edge. It goes directly to the front-end transport service running on port 587. Okay, now let's go through some mail routing scenarios. I'm going to go through about 4 of them. This is the same knowledge that I mentioned before, which is front-end transport's job is to look at the recipient. If there are multiple recipients, so actually let's start from the top. When you get a mail item, piece of mail, it could be to 1 recipient, 2 recipients, 10 recipients. Front-end transport will always anchor to just 1 recipient. So it'll pick 1 recipient, okay? And it'll use that recipient to do its routing. So if it picks a recipient usually picks a recipient that's local, that's in the mail, that's basically in your organization, and it'll pick up that recipient, try to find the mailbox or try to find the DAG for that recipient, and then it'll send that to the mailbox server in the DAG. Oh, this is preferably the same site as the CAS box. That is 2013. So, all right. So let's see how this works. So you have one machine. Let's understand this there. You have one machine that's a mailbox server. It has all the three transport components, and there's a mail item coming in for this person in purple. So front-end transport service receives this on port 25, determines which DAG, since it's the same, this DAG, there's only one DAG here, it will send the mail to the transport service on 2525, processes it, sends it via mailbox transport on 475 to the store. If you look at this sequence of events using the protocol flow, this is what it looks like. So you have from the internet SMTP server that's trying to connect to the front-end transport box. It goes through the regular SMTP protocol of an ELO, a 250 OK, a mail from, receipt to, and then when it starts sending data, it's at this point that the front-end transport process has the recipient. It has to wait for the receipt to get the recipient. It anchors on that recipient, finds which transport service to talk to, and then establishes a TLS connection to that transport box and authenticates with it, and then sends this verb, this X proxy from verb, which is specific for internal exchange, which is telling the transport server where this mail is coming from. So the X proxy from, if you look at the protocol, would be something like this mail is coming from this IP address, this server, all the information that it knows, because the front-end transport is the thing that's actually internet facing, that's actually talking to the server that's exchanging mail. Now, the front-end transport then transfers the mail from, the receipt to, and the data fields to the transport service. Once the transport service has received all that data, that's when it'll reply back with the 250 OK. I have now stored that piece of mail. That piece of mail is now my responsibility. And it will return back a 250 OK. Eventually, the destination or the sender will quit the connection once it has sent that mail item. Communication between the transport and the mailbox transport service looks like this. I told you it's SMTP now. What it's doing is basically saying, hey, now it's talking to the mailbox transport service that's on the box where the mailbox is. It's doing the regular ELO 250 OK exchange auth command, so it's authenticating. And now there's this verb that's passed, which is X sessions params. And it's in this verb that we send information to the mailbox transport service as to which database this user belongs to. So the mailbox transport service knows to open a MAPI connection against which of the many databases on the machine. Okay? So the transport service has already looked that up. It knows exactly where to go, which database, and that's the information that's passed in the X sessions params verb. After that, it's the regular SMTP protocol, mail from, receipt to, data, and the connection closes. So this is the whole end-to-end flow if you look at it from internet to front-end transport to transport and finally mailbox transport. What about the received headers? Go quickly through this. That same piece of mail that was received from the internet, it has gone through it has actually been received on the same box by 3 separate services. That's why you will see 3 headers for that same piece of mail, even though it's on the same box. The first one at the bottom is via front-end transport, because that's what received it first, followed by just transport, followed by mailbox transport. So don't be surprised if you see, oh wow, why is this box receiving this mail 3 times? It's not receiving it 3 times, it's just moving through the 3 services that are on that box. Okay? All right, what about incoming mail to 2 recipients? So I'm sending email to recipient red and recipient blue. I mean, at this point, I want to just make a disclaimer. I know I'm using color to basically mention about people, but please don't read too deeply into that. Okay? I mean, any resemblance to anybody in this audience is purely coincidental. All right. So that being said, this piece of mail is destined for Mr. Red and Mr. Blue. Once again, the load balancer picks something, picks the front-end transport. You notice that the mail did not stop at front-end transport. It was just proxied through, because the front-end transport it doesn't store that mail. It just quickly receives it, looks at AD to find out where which DAG the user resides, and then sends it along its way to the transport service. It's the transport service that's actually now doing the processing. And once it's figured out that there are two pieces of mail, two recipients, it's going to bifurcate that mail and send one via the mailbox transport service to Mr. Red. And because they are both in the on the same, this is the same box, so it's really quick. And in the other case, it can still talk to the mailbox transport service on the other machine. Notice that communication is SMTP. It can send that piece of mail as long as both the boxes live in the same DAG. Okay, so this is one DAG I've drawn. So you can go from transport to mailbox transport to store in the same DAG without having to go. But the cross-machine communication is SMTP. All right, what about originating mail? So what about when I press the send button? This is one of my users trying to send a piece of mail to the internet. That piece of mail gets submitted, mailbox transport picks it up, and will send it to the transport service, as I said, on another machine. Once that machine receives that piece of mail, it will process it, and it knows that this recipient is external, and it will therefore use your internet connector or your smart host connector to send that mail out. And this is also assuming it went through front-end transport. Did you notice? And the reason why it went to front-end transport is because you had set that field or that flag in your send connector to route mail via front-end transport. If you had not set that flag, it would just go out without going through front-end transport. So what does the stack look like in this communication? So we did the incoming stack. What does the submission stack look like? You have the mailbox transport service establishes a connection with the transport server. Now when it receives a piece of mail, the submission service does something very similar to front-end transport. It anchors on a recipient, and determines which transport server or service should I send that to. Okay? It picks one of those transport services and then relies on the transport service to do the rest of the routing. So this is a very simple protocol. It's mail from, receipt to, data, quit. And once transport receives it, now the thing gets a little bit interesting. When transport after it has processed this mail and wants to send this piece of mail out, what's it going to do? It's going to establish a TLS connection with the front-end transport server. Now, remember, the only service that's talking outside is the front-end transport service, not in this case, because I've set that flag. So we use a verb called xproxy2. xproxy2 basically will tell the front-end transport service that, hey, please send this piece of mail to this destination, to this IP, or to this, server. And that's what the xproxy2 will contain. After that, the front-end transport establishes that connection and is simply a blind proxy. It does not read what's going on the wire. It'll just send mail from transport will go and send a mail from to the internet and so on. So you can see it's different from the communication that came in. In this case, it's pure. Once it has established that connection with the destination, after that it's just a blind proxy relaying the commands from the transport service to the destination MTA. So this is what it looks like from, in this case, right to left when you submit a piece of mail. So putting this all together, what do we have? So in this case, one of the users wants to send a piece of mail to 3 recipients. Mr. Purple, that lives in the same DAG as the sender. Mr. Orange, that lives in a different DAG as the sender. And then somebody on the internet. So when it goes to mailbox transport in this case, let's assume it anchors on the recipient Purple. Okay? Because it anchored on recipient Purple, it had 3 recipients to choose from. Chances are it would choose either recipient Purple or the recipient Orange, and it would pick that one up. In this case, recipient Purple, send that mail to the transport service on the other box for processing. This is the transport service here determines now the route for each of these recipient mails. So it determines that one of them needs to go to the mailbox transport service and which eventually to the store, the same DAG. Now the other one will go from front-end transport to the internet. And where do you think this piece of mail will go? How many of you think this piece of mail will go from transport to mailbox transport? No. Because that other user belongs in a different DAG, transport will go to transport. Okay? So the transport service does not have the ability to send a piece of mail to the mailbox transport service outside its DAG. All right? So it only will deliver that mail within its DAG. And then if it finds out that there's a user that belongs to a different DAG, it'll send it to the other transport service for it to do its thing. And that transport service will process the mail and send it to the local box. Okay? So that's routing for you really quick. I want to move on to high availability. I mean, I told you I have kind of a packed session. I still have to cover Office 365, or at least some of it. So that's why I don't want to lose the pace here. Okay, what we have here is shadowing. Now, one of the things that we take very seriously is obviously once we accept a piece of mail, we do not want to lose that piece of mail because the sender has given that responsibility to us to keep that piece of mail and deliver it. So we have shadow in transport. We had a poor man's shadow in Exchange 2010. This is a better version of that. Let's talk a little bit more about it by actually with the help of this diagram. So remember that piece of mail coming from the internet to Mr. Red. Now, what I showed you before was that piece of mail came to front-end transport, which found the transport service. Notice what happens now. The transport service on the box will not accept a piece of mail if it cannot shadow it successfully to a different box. If shadowing fails for whatever reason, because the other box is not available, or if you only have 2 boxes and yes, the other box is not available, that's too bad. If you have multiple boxes, it will try to shadow it to a machine, another machine in the same site, or different site rather. If that's not available, then it will shadow it in the same site. Okay? And this is all for redundancy purposes. So you saw what happened. Mail came in from front-end transport and went to the transport service which shadowed that mail before accepting it. So now you have 2 copies of this mail. The transport service will then go and deliver 1 copy like it normally does to the store. Notice that it still has a copy of this mail in its safety net. Remember I showed you when the mail came in, the first thing we did was save it to the mail.q database. That's the piece of mail in the mail.q database. We've submitted the mail, but there's still a copy of that mail with us in mail.q. And the reason we have that in mail.q, it's what's called the safety net feature, is in case something happens to store, and store has lost that piece of mail before it has a chance to replicate it out. If it's lost that piece of mail, it can go and re-request for that piece of mail from the transport service, and the transport service can send it back to them. And that's why you'll see sometimes in message tracking, if you see duplicate delivers, that's usually shadow trying to send a mail on behalf of the second time to the store. But it doesn't even stop there. Now what would happen if, so now that this mail, by the way, gets delivered, look what's happening. The transport service on the shadow box is constantly pinging via SMTP again this primary server. And it's telling the primary server, hey, have you delivered this mail? Hey, have you delivered this mail? Hey, have you delivered this mail? And the primary server will come back eventually and say, yes, I have delivered this mail. When it has delivered this mail, that transport service knows that it no longer needs to deliver this mail because that has already been successfully delivered. It will save a copy in its safety net, known as the shadow safety net. So at any given time, literally, you have 3 copies of that mail, one in store, one inside the primary transport service in the mail.queue, and the other one in the second or the shadow transport service also in mail.queue. The transport services will keep that piece of mail for, I think by default, 7 days. But if you want to see, you can adjust those values based on with this commandlet you see in the last bullet here. So you can go and do a get transport config and look at what the heartbeat frequency is, what the resubmit timestamp is, and so on. So in the previous diagram, if something happened to this first box at all and store had not had a chance to replicate that out, so basically that machine had a hardware failure and no longer exists. You still have the shadow, safety net shadow on the other box that store can retrieve that piece of mail from. Okay? So there's a lot of redundancy built into the system. Now, if the shadow keeps pinging the primary and the primary says, well, primary does not respond because it goes down for whatever reason, the shadow will submit mail on behalf of the primary, okay? It will send mail on behalf of the primary, and that's what I meant by duplicate delivers, or shadow delivers. You see shadow delivers, you'll see duplicate delivers in message tracking. So you remember this protocol that I showed you before, the protocol flow coming from the internet outside? Well, I actually lied a little bit to you guys. So it's not, well, there were only 4 people who were honest about their coffee intake. So the protocol is true for the most part, except for this last piece here. Mail is coming from the internet. It's going to front-end transport like I explained before. But the difference is this transport server 1, once it starts receiving data, it will try to now establish a shadow session with another transport server and communicate with it first before it says OK to the original request. So you can see there's a lot of talking going on for a single piece of mail that's coming in from outside. All right? It's going from internet to front-end transport to a transport server on one box, trying to shadow it on another box. You can see the shadow request parameter that we use. And then finally, that shadow server, once it says, yes, I've received it, thank you very much, we will close the connection with the original sender. So this is truly now the end-to-end workflow or protocol flow of a single mail being received by transport. Now, after that is done, you will notice that these 2 servers are also talking to each other. They are, you can see the shadow server saying, hey, I'm doing an X shadow. Do you have anything for me to discard? Which basically means, have you submitted those pieces of mail? And the primary server will come back with, yes, I have, with message ID A, message ID B, message ID C. And that gives the server 2 the idea that it needs to discard its messages. Which brings me to the last slide before I move on to Office 365. I mean, this is actually, believe it or not, a non-animated slide. So if you're looking for animation on this one, it's not happening. At this point in my slide deck, I had what you call animation fatigue. And I was like, you know what, let's figure this one out without animation. So anyway, that being said, I mean, I enjoy message tracking. In fact, that's one of the primary ways of which you debug or find out where your mail went or what's going on. And you'll notice over here, mail came in via front-end transport. So I'll go through both of these diagrams, and I will talk about delivery first, then submission. So mail came in on front-end transport. Note there's no message tracking on front-end transport, so you won't see any event there. But you will see, by the way, before I move on, is everybody familiar with message tracking? Okay, good. All right, that's overwhelmingly yes. That's good. So you come in, SMTP receive, that's the first event you will see. You will also see, I mentioned the number two times because before you see an SMTP receive, you'll actually see an SMTP HA redirect message. Okay, you'll see an HA redirect message, which is basically telling you that that message was successfully redirected to the shadow server. And you'll see a corresponding HA receive message on the other side. When I say message, it's a message tracking message, okay? It's the event ID, HA receive, and the source being SMTP. You'll also see an SMTP send event on the transport box because it's now sending that mail via mailbox transport to the store. And the authoritative way to know that the mail was actually received by the store is to see a store driver deliver event. Okay, we know that, I guess. What about on the now? Also mentioned that you'll also see an HA discard event on the other box, on the shadow box, once it has discarded the shadow copy. Okay. What about on the way back from the store? When it submits the message, you will see a store driver receive. That's receiving the message over MAPI. Store driver receive is receiving it over MAPI. Store driver submit is submitting it from a mailbox transport to the SMTP receive to the transport service. Oops, sorry, I forgot I had no animation on this one. The SMTP receive on this box. That's when you notice that again. I've put twice because before we receive. The transport service, whether you receive it from the internet or from mailbox submission, without a shadow, it's not going to accept that mail. So you'll see an SMTP HA redirect, followed by an SMTP HA receive on the shadow server. And finally, you'll notice that HA receive on the shadow server. Finally, you'll notice that SMTP send, sending that mail out. So that's message tracking. So let's talk a little bit about mail flow in Office 365 at this point. So what we have here is, I want to first spend a couple of slides on what's new in mail flow in Office 365. All right. Now, the first thing that we've done, one of the things that we've done is basically, I don't know if you're familiar with connectors. We used to call in the service, we used to call them inbound, outbound connectors in the past. You guys familiar with connectors in the service? Actually, how many of you all are in the process or moving to the cloud at this point? Okay, I presume the people who are leaving this room right now are not. So anyway, I had a session earlier where I spoke in depth about connectors and why you need them. I won't be going through all of that right now, but I will be talking a little bit about it in my next few slides. But we have revamped that UI considerably. In the past, that piece of UI was not good, to say the least. I mean, it was a single page and required a person to understand esoteric stuff to determine how to basically set their rules and so on and so forth. We now have a walkthrough, a wizard that guides you through this. So if you can pick up my session from earlier, it actually has details on how to do that. The other thing that we've done is we've increased the max message size for messages in the cloud to 150 MB. This is not happening on-premise. You guys have the option on-premise to change your defaults anyway. But we've changed it to 150. You can go up to 150. The default is still 25 in the cloud. But you can configure it. You can also decrease it. I mean, believe it or not, some folks, some customers actually wanted to decrease it from 25 to like 10 MB because they wanted to be in sync with their on-premise, which was at 10 MB, for instance. So they kept it at 10 MB. There's more on this in this link that I have here. The other thing we've done is we've increased support for SMTP TLS. Now we support TLS 1.2. But that also means we've removed support for older, not so robust protocols like SSL3 and in the upcoming months RC4. This means if your MTAs are not sending mail over TLS 1.0 or higher, that's going to be trouble. The other piece also means, but most Exchange servers all send about with TLS 1.0 and above. And I told you TLS 1.2 also ships its CU8 for 2013, so that should be no problem too. But if you have old printers, that could be a problem because old printers might not work with TLS 1.0 if they are sending mail to users in the cloud. This is again in the cloud, okay? Finally, we have revamped or enhanced our NDRs in the cloud. I don't know how many, any of you familiar with the enhanced NDR feature? You're not? No. Okay. No, I saw somebody from my team. I said, don't raise your hand. You know that. All right. So we have, this is what a new NDR, enhanced NDR in Office 365 will look like. Okay. No longer will be, I don't know, how many of you guys, I guess most of you all are probably IT pros, so you guys revel in these NDRs. But for most customers who look at an NDR, they are lost. End users, unfortunately, are the ones that receive NDRs. And when they see one, some of them even get scared. So we try to change that, especially in Office 365, because a lot of our customers are small businesses. And when a small business owner or somebody who is running a bakery shop sees an NDR, they're not quite sure what to do with it. So we've changed the look and feel of the NDR. You'll see in this case, we very clearly state, for instance, that that Khushroi, I misspelled my name intentionally, and it wasn't found in my domain. And it tells you who needs to take action. So as an end user, you know, is it the sender that needs to take action? In some cases, it could be the recipient that's at fault if they have, say, a transport rule or something that's blocking the mail. In some cases, Office 365 could be at fault in case we are unable to deliver that mail. But it'll tell you who's responsible, so appropriately, that individual can take action. In this case, it's the first bullet there, where we say, hey, if you may have misspelled it, you may want to retype the address. We have actually gone ahead and broken our NDRs into issue-specific NDRs. So no longer will you just see a 5.7.1 for, unauthenticated mail not being able to go through. You will actually see a 5.7.12 or a 5.7. Something else, very specific to the issue that's on hand. Right now, this feature is only in the service. We have not extended it outside. The other thing that we've done, the same piece of mail, as you scroll down, we've also made even the existing tables. We all like the various hops, but we've made it such that the hops look much neater, so you can actually understand. Otherwise, I don't know about you guys, but most people just cut and paste the header into a tool that actually does exactly the same thing, right? So this is really doing that for you without having to go there. And for those of you who enjoy reading the current NDRs as they are, at the bottom of the NDR, you'll actually see the current NDR as is, nothing unchanged, in case you're still used to seeing the old format. But for the first impression, we'd like to leave a good impression before we said what was there before. Folks have called this oxymoron, right? Kind of a joyous NDR. No one wants to receive an NDR, yet when you receive it, you want to know what to do with it. All right, let's actually do a quick session here on Office 365. Now, I want to start with most of you. Here I'm not going to talk about SMBs here. I'm going to talk about the enterprises. So you have Contoso.com, that's an enterprise, with their MX record actually pointing to Contoso.com, and you can see what their MX looks like today. They have a mail.contoso.com and mailbackup.contoso.com. In this world, mail from Bob at yahoo.com, so from the internet. That globe, by the way, is the internet. From yahoo.com, when it needs to send a mail to John at Contoso, it would go directly to Contoso.com because the MX record points to Contoso. However, Contoso.com, like a lot of organizations, has decided to move or take one step in the direction of the cloud. The first thing that Contoso.com is going to do is going to register their domain as an accepted domain in the cloud. What that tells us is that you own your domain. You have to verify your domain before you can register it. We won't just have anybody register any domain they want, otherwise that would lead to chaos. And so you have to register it, prove ownership for it, and you do that by adding a text record in DNS. You add a few users of yours that you want to host in the cloud, and you move your MX to O365. When you move your MX to O365, this is what your MX looks like. It actually points to contoso-com.mail.protection.outlook.com. With that particular address, you could get multiple IP addresses associated with that. These IP addresses are region-specific. So if you registered if you're coming in from North America, you would get North America IPs. If you're coming in from Europe, you'd get European IPs and so on. So you do get region-specific routing for your mail. That being said, a lot of companies prefer to keep their MX records still pointing to their on-premise servers. They want to move to the cloud. They move some mailboxes there. But while that is definitely supported, it can lead to a little more failures with regard. I mean, routing complexity increases a little bit. And as a result, in the new age, where we have SPF records and DKIM checks and DMARC checks, you're better off with the MX actually pointing to Office 365 in this move. But that being said, the other option is also fine. I'm only going to be talking about when the MX points to Office 365. I won't have time to talk about the other option in this session. I spoke about region-based IPs. So let's see. Let's talk about I mean, this is just a very high-level overview of connectors. This is no means the details. Details is in the other session. Why do we need connectors? Or what's the primary reason for having connectors? We all want one happy organization. Well, let me ask you actually this. Do you all want a happy organization? Only few hands, so maybe not. Maybe I should stop. I should stop. Okay, well, for those who don't want a happy organization, let's talk outside. Meet me after this session. I mean, there's a lot more going on in your life. Let's talk about this happy organization that we have. You know, here, when I say happy organization, what I mean is you want it seamless. You don't want a user, like in this case, a user in the cloud and a user on premises, to even know the difference. You don't even want to know that your mailbox is actually in the cloud. You want to have a seamless experience for these users, just like they were on premise. And that's why you create these connectors, because one of the primary things these connectors do is allow you to retain your Exchange headers. Now, if you're not running Exchange, that's a different story. But if you're running Exchange, that seamless integration happens because if you didn't have these connectors, and I'll talk about them in a second, those headers would not be retained. We would strip them off. And a lot of things would get broken because of that. And a lot of things means a few things. So let's see what we do here. So the first thing we do is we create a connector from Office 365 to your organization servers. I've kept in braces is the old name. What you also will see in PowerShell, we've not changed that. But we've given a specific direction to your connectors. So you have from O365, you create a connector from O365 to your organization for all accepted domains. You'll also create a receive connector on your on-premises server that's accepting mail from our IPs. Finally, in this case, when Jim wants to send a mail to John, Jim is in the cloud, John is on-premise. That piece of mail going from Jim to John, you will see that piece of mail, when it goes out, it will use that connector, and we will keep the headers as it moves from the cloud to the on-premise server. So when mail comes on the other side, it's analogous to as if mail came from within the data center on your premises. The same thing goes for when Bob at yahoo.com on the internet is trying to send a mail to you. It comes to the service figures, okay, I need to send a mail to John. Well, John doesn't exist in the cloud, so I'm going to send that mail over using this connector to the on-premise server. And it's exactly what happens, and it goes and reaches John's mailbox. Now, I have not gone into details of the kinds of domains you have, like authoritative, internal relay, and so on, because that's going to be too much in this session. As it is, I think I'm probably extending it. That being said, though, I want to let you know one thing. If you're ever worried that, mail coming from outside, if it's trying to get to your smart host and your smart host doesn't work for whatever reason, it's down that day, or say your smart host, or your certificate is expired and you didn't realize that, we will actually, mail starts getting queued over here in Office 365, and when it starts getting queued at a certain threshold, we would actually post the message to your message center, which is in your console, in your Exchange admin console, or actually in this case, your Office 365 console, informing you that your messages are being delayed for some reason, and for you to take action. Now, most of us don't keep looking at that dashboard every day, so we won't know that there's something wrong. But we also have another mechanism to let you know, and that's what's called that's an email. Well, that's what's called an email. That basically will be sent to your administrator, most likely on an alternate email address, and so you would know that there is something wrong. So if you are hesitant on, hey, what if mail is stuck in the cloud? Will I come to know about it? Yes, you will, via this notification mechanism. I'll also talk about John trying to send mail to Jim. So this is John on premise trying to send mail to Jim. When you have mail coming from your organization to Office 365, you need to set up a send connector, informing your org that all mail is going to contoso-com.mail.protection.outlook.com, followed by a connector on our side, which basically says, hey, this is accepting mail from your organization to Office 365. All of this can get confusing, okay? I know I realize I'm going pretty fast too. But I think the main takeaway from this part is not so much this is simply the mail flowing from John to Jim, as you can see over that connector. The main takeaway for me over here, or rather for all of us, would be that you need to set these two-way connectors from your organization to Office 365 and from Office 365 to your organization if you want the seamless flow. Okay, so this is the slide actually I want to get to. You can see I've created a pair of connectors from Office 365 to us, and to the organization, or from the organization to Office 365. And when you do that, that's what gives you the capability to keep those internal headers intact. So if you're ever worried that, oh, if I move to the cloud, I'm going to use that tight integration that I have on premises, that won't happen when you have your connector set up correctly and configured in a way where we actually keep the headers, okay? The last thing I want to talk about is just this one slide, which is in order to keep those headers prevent those headers from being stripped, these are the instructions you need to follow. So it's not just setting up the connector, but also on both your organization as well as in Office 365, you need to set some flags. And only if you set those flags will the the X-MS- Exchange organization headers are preserved. Otherwise, they're always going to be stripped. So on this very confusing note, I'm going to stop, and I'm going to take questions. I have about 5 minutes for questions. I'm also going to be outside, so if you have questions for me outside, feel free. And I have my card, so if you need to pick up a card, do that too. Thank you. Thank you. Thank you very much. This just got cut. Did I lose? Okay. Do you mind, actually, since we have 5 minutes, I wouldn't mind taking questions over the mic so that everybody can listen.
The question is, does Hybrid Configuration Wizard create or change the connectors you mentioned?
No, actually, I forgot to mention, but HCW, a Hybrid Configuration Wizard, will do exactly this if you fill it correctly. So it creates these two connectors for you to give you that seamless experience. I'm not sure if it goes and touches the right attributes. That page which I showed you, which on the send connector you need to set those things up, it might or it might not do that, but just want to verify that when you use HCW. But those are key to make sure that your headers are preserved.
I've got a couple quick questions. The first, if the categorizer is bifurcating the messages before it sends it out, why the need for multiple delivery queues?
So when I say bifurcate, I mean it's the same copy of the mail that now needs to be sent to 2 destinations, right? And each destination might have different requirements, and different connectors. When you're sending a mail to your mailbox using a different connector than what you're sending to the internet, for instance. And that's why you have queues. Each queue uses a different connector.
Okay, the second question, on the cross-DAG transport, how does it choose which server transport service it goes to? What happens if the one it chooses isn't there? If the server's offline, for instance?
So you're talking about the submission service when it tries to send mail?
Correct. If it's trying to send from DAG to DAG, and it's going from transport to transport you said it picks one at random?
No, it actually anchors on a recipient. So if I'm sending a mail, and I'm sending a mail to 2 people, it will anchor on one of them, and so it just pick one of them. When I say anchor, I mean just pick one of them, and it will look at that recipient and determine which DAG that recipient mailbox belongs to. And based on that, it will route the mail to either its own DAG, if that mailbox resides in its own DAG, or to a transport service in a different DAG, if it resides in a different DAG.
Right. If it's in another DAG, though,
Yes.
how does it choose which server in that DAG to go to?
It actually it could choose any server, but again, I think it prefers the server in its own site.
Okay, and then last question, what happens if that server's offline?
You said 2 questions. This is your third.
Sub-question. What happens if the server in the other DAG's offline?
It's not there. I mean, it'll try to submit it to at least, any server in that DAG. So it'll try one first in its own site. If that doesn't succeed, it'll try another server in a different site, no problem. But one of how many ever servers you have in your DAG, it's got to be available. If none are available, then that's kind of bad. Yeah, no problem.
So if you're sending via an internal connector, is there anything that would stop you from sending that via, say, a mail appliance or something? So long as you're not stripping out that X header, is there a problem with relaying that mail through a dedicated gateway?
So if you are sending it through a machine or an appliance that's not touching anything in that mail, like stripping off the headers, then you're okay.
So you could go like 365 to ironport and then ironport to exchange, so long as ironport wasn't messing with header.
That is correct. I highly doubt that, but you might want to verify. Whether they don't mess around with that stuff.
Cool.
Yeah. But actually, before you go there, sorry, one other thing though. Ironport is okay because it's a device that's not touching any of those headers, but make sure that you don't have another service sitting between us and the cloud. Between your organization and the cloud. So that's important. Okay. All right.
Hi. Do you know if NDR Extended is on the roadmap for Exchange on-prem?
Not at this point. No.
Thanks.
Would you like it to be? Yeah. Like it to be branded? We'll charge for that.
When it comes to the sending outbound messages through the front-end transport or
Yes.
front transport,
Yes.
is there a benefit to having it do that proxy function versus the transport just send directly out?
The only advantage is people like that extra level of indirection because their hub transport is not directly talking outside. So if they are paranoid about that part, that's the only reason why, but nothing else.
On 2013, both those roles are on the same box.
That's correct.
so it's still-
Well, in 2013, both the roles are not on the same box. 2016, they are. So the front-end transport actually lives on the cafe box or the CAS box.
But if you had CAS and mailbox...
But if you have on the same machine, yes. If it's the same box, the box is exposed, no problem.
In a hybrid setup, you said that if a message comes in for someone who's not on the O365 side, it gets queued before it gets sent to the on-prem.
Well,
Yes.
it gets queued. Is that your question, or you want to proceed? Sorry, I might
Well,
have
actually, no.
interrupted.
Basically, I wanted to know is if, let's say, the on-prem site was down, would it continue to queue messages until the on-prem site came back up?
Yes, it would.
For mailboxes that are, for mailboxes that aren't in the old 365 side?
The answer is yes, with one difference. When mail comes in and we are trying to deliver to on-premise, your server is not available, so we keep retrying. It's kind of I think we have a progressive back-off mechanism, so we'll try it very quickly first, then we'll kind of back off. It also depends on the error we get back from your smart host. If your smart host returns back a 500 to us, we are rejecting that mail right away and issuing an NDR back. We're not queuing at that point. If your smart host returns a 400 or it's not available, then we will queue that message. We'll keep it in our queues for 2 days, after which you will get NDRs back. So you have 2 days before you can rectify or get your smart host back and up and running.
Okay, I was just thinking in terms of evenings where we might perhaps have to do maintenance on the
No, that should not be a problem. I mean, well, it's a problem for the service. We hate to queue your mail and keep it on the service. but no, if you had the occasional maintenance, that's what's going to happen.
Okay, thank you.
So I'm actually out of time because I'm past this. I know there are two of you. I won't take your questions. No, stay there. Let me just come out there so that the next speaker can come in. That's all. Okay? But please stay there.